So in this video lecture, let us solve certain numericals. What is given here is a particle moves along a circular path of radius 300 mm. So a circular path is set. That means that this radius is not going to change. It means that of course it's moving along a circle. So if I consider origin O or the center of this circle as the origin, then this radius is not going to change throughout, right? That means that the particle is not moving along the radial direction. That is what we can understand from this. One more thing is say that the angular velocity theta dot is 3t square radians per second. Now this theta dot is nothing but d theta by dt. Okay, nothing is given. Determine the magnitude of the particle's velocity and acceleration when theta equals to 45 degrees. So first of all, in these cylindrical coordinate numericals, what we need to remember is the formulas for the final velocity and final acceleration. So velocity is given as under root of vr square plus v theta square, in which vr is dr by dt and v theta is r into theta dot. Okay, and if we talk about the acceleration is under root of ar square plus a theta square, where ar square, ar is given as r double dot, right? Ar is given as r double dot minus r theta dot the whole square, and a theta is given as r theta double dot plus 2r dot theta dot. Okay, so these formulas we need to remember. From this we can understand that what we actually need to find, right? So now see, r is given as r is basically 300 mm and it is constant, right? So there won't be any change with respect to time in r. Means change in r with respect to time, I am saying means it won't move like this in this direction or this direction with respect to time, right? So what we can say is that dr by dt or r dot is equal to 0. Similarly, r double dot is equal to 0. What change is going to happen is only with respect to theta and not in the direction of the radius, right? So theta dot is there. Theta dot we have as 3t square, right? So what we can find from this is since this is equal to d theta by dt, therefore d theta integration going from 0 to theta is equal to 0 to t 3t square dt. So this will give me theta is equal to t cube, right? It will give me theta is equal to t cube. Now what can we do about this thing? What is asked is determine the magnitude of the particle's velocity when theta is 45 degrees. So when theta is equal to pi by 4, at theta equals to pi by 4, you can find t. You can put this t in this theta dot, so you will get the theta dot value. Okay, r we already know it is 300. Okay, so v theta you will get, vr is anyways 0. In AR, r double dot is 0, r into theta dot square you will get. Theta double dot is what we need to find. So theta double dot now, that is the derivative of this, will be 6t, right? So again, when you find t here, you can put this and you will get theta double dot as well. So let us find t, what we get, let us see. So at pi by 4 equals to t cube, we get t is equal to 0.92263 seconds, and this t, when we put in theta dot and theta double dot, we'll get both of those values. So theta dot we have as theta dot will be 2.5537. Okay, it is radians per second, and theta double dot will be 6 into 0.92263, which is 5.5358 radians per second square. Okay, So now we can just put and we can find VR and V theta values. So VR value, VR is 0, V theta is R into theta. R is given as 300 mm, right? 300 mm is the R. I'll convert it into meters, so it is 0.3 into theta dot, right, which is 2.5537. This is equal to 0.76613 meters per second, 13 meters per second. And similarly we can find AR and A theta. AR is equal to R double dot, which is 0 minus 0.3 into 2.5537 square. This is equal to minus of 1.9564 meters per second square, and A theta would be R theta double dot. R is 0.3 into theta double dot is 5.535 plus 2 into R dot theta dot. R dot is 0, theta dot whatever it is, so this term is anyways going to come 0. Okay, right? So this is 0, so therefore this will get us 1.601 meters per second square. And then of course finally you can find your total velocity, which is under root of VR square plus V theta square. VR is anyway 0, so this is your magnitude of the velocity. And we can also find the magnitude of your acceleration, right? So this completes the first numerical. So what is given in this question is the position of a particle is described by r equals to t cube plus 4t minus 4 meters. So here what we are seeing is that r is also varying with respect to time, therefore r is not constant here. So r is equal to t cube plus 4t minus 4, and theta is equal to t raised to 3 by 2. So both r and theta are varying with respect to time. We need to find the magnitude of the particle's velocity and acceleration at the instant of t equals to 2 seconds. So fine, VR is nothing but r dot. I'll just write directly. VR is r dot and V theta is r theta dot. AR is r double dot minus r theta dot square. A theta is r theta double dot plus 2r dot theta dot. Okay, so these are the values that we need to find. Let us find quickly. So r dot will be 3t square plus 4, r double dot will be 6t, theta dot will be 3 by 2 into t raised to half, and theta double dot will be 3 by 4 into 1 by root t, right? At t equals to 2 seconds, quickly we can find this. So at t equals to 2 seconds, all the values we can find quickly here itself. So r dot will be 16 meters per second, r double dot will be 12 meters per second square. Okay, theta dot will be 2.1213 radians per second, and theta double dot will be 0.5303 radians per second square, right? Now you might be wondering that when this theta dot square and all comes here, even the acceleration, so the unit of this term will be like meter into radian square upon second square, right? But you see that this quantity, this units are actually dimensionally homogeneous to acceleration, although this radian does not appear in the acceleration units, but this radians is actually a dimensionless quantity. Therefore, these units are dimensionally homogeneous to your acceleration. Hence, this is correct. Okay. Now, we also need the value of only r, right? So r is actually t cube plus 40 minus 4. So r is equal to, when you put 2 here, you will get it as equal to, let us calculate how much is that. So 12 meters, you will get that. Okay. And now it's just final substitution. So this is directly a VR. We don't even have to calculate it anymore. VR. Okay. VR is equal to 16 meters per second. V theta is equal to 12 into theta dot, which is 2.1213, right? And AR is equal to R double dot, which is 12 minus 12 into 2.1213 square. A theta is R theta double dot, so it is 12 into 0.5303 plus 2 into R dot theta dot, which is 16 into 2.1213. So you all can calculate it, and finally you will get the magnitude of your total velocity and total acceleration, right? So what is given in the question is that the slotted arm OA rotates counterclockwise about O such that when theta equals to pi by 4, arm OA is rotating with an angular velocity of theta dot, okay, and an angular acceleration of theta double dot. Determine the magnitude of the velocity and acceleration of pin B at this instant. The motion of pin B is constrained such that it moves on the fixed circular surface and along the slot in OA. And the equation of R is given. R is 2A cos theta. Okay. So what we can do in this is, since the angular acceleration is given as theta dot, what we'll do is that we'll take the time derivative of this equation. It will be dr by dt, which is actually your VR. Okay, this is equal to 2a into minus 2a sine theta into d theta by dt. This is nothing but minus 2a sine theta into theta dot. Okay, see, no values are actually given, so we are not going to get the answer as a value, but we are going to get it as a expression maybe. R double dot is again we require it for finding acceleration, so this is R dot, this is R double dot, which is minus 2a cos theta. So now see here what happens is, since we are taking the derivative of this thing and both of them are function of time, we'll have to take the product rule. So u, if I consider this as u and this as v, then u derivative of v, which is theta double dot, plus v derivative of u, so plus v into derivative of u is minus 2a cos theta into d theta by dt, which is theta dot. So this will be minus 2a sine theta, theta double dot, plus theta dot the whole square. Sorry, this would be minus, right? Minus theta dot the whole square into 2a cos theta. This is what we'll get. right? Now at theta equals to pi by 4, since these theta dot and theta double dot are at theta equals to pi by 4, so we can put this theta here, we'll get some values. Let us see what we get. Even in this r we can put it. So you see, actually uh, for that velocity, uh, I'll just write the equations here once again. So Vr is r dot, V theta is, or instead of wasting time in writing the equation, let me just copy it from above. So you see, this is what we had required. R dot we need. Theta dot and theta double dot are already told that they are going to remain that only, theta dot and theta double dot. We needed the values of r dot and r double dot, right? So that we have found, and also we need the value of r. So that also we'll find how much is r in this. So when theta equals to pi by 4, r is equal to 2a cos pi by 4, right, which is root 2a. R dot is minus 2a sin pi by 4 into theta dot, which is minus root 2a theta dot, and r double dot is equal to, when you solve this, you will get it as minus root 2a theta double dot minus theta dot the whole square. Okay, so this is what we got, and now it's just mere substitution in these values. So your Vr is your r double dot, so this is directly your Vr. Vr is minus root 2a theta, or rather I'll just now directly find the total velocity, final velocity. It is under root of minus root 2a theta dot the whole square plus r theta dot. R is root 2a and this is theta dot, this would be the whole square. So you would get this as 2a square theta dot square and plus 2a square theta dot square, right? So this would be like 2 times 2a square theta dot square, which is like 4a square. Okay, so this is 4a square theta dot square, which will be 2a theta dot. 2a theta dot. So this is your final velocity, the magnitude of the velocity, and your acceleration. Acceleration is r double dot minus r theta dot the whole square. R double dot is, okay, so this could take a while to solve this. That would be like r double dot is minus root 2a into theta double dot minus theta dot square. This is r double dot minus r theta dot square, which is minus root 2a into theta dot, a is outside, theta dot square, this square, right, plus r theta double dot, so root 2a theta double dot plus 2r dot theta dot, 2 into minus root 2a theta, so root 2a theta dot 2r dot theta dot. So this would be again theta dot square, this square. Okay, so this is your final acceleration. You can simplify this further. So acceleration is under root of, this would be like minus root 2a theta double dot, and this is plus root 2a theta dot square, and minus root 2a theta dot square would get cancelled out, right? Plus root 2a theta double dot minus 2 root 2a theta dot square. So what we can take common here is, we would take root 2 as common, and its square would be outside like 2, okay, and a theta double dot, or we could also take a common, right? So this would be 2a square, 2a square outside, and we will get theta double dot minus 2 theta dot square, the whole square. And from this, what we can take is, this would be 2a square theta double dot square. 2a square would be, we can take it outside as root 2a under root of theta double dot square plus theta double dot minus 2 theta dot square. So you can further simplify this. I would not simplify it more. I'll just keep it this way. Okay, so this is the final magnitude of the acceleration. Okay. So what is given in this question is, starting from rest, the boy runs outwards in the radial direction from the center of the platform with a constant acceleration of 0.5 meters per second square. If the platform is rotating at a constant rate of theta dot equals to 0.2 radians per second, determine the radial and transverse component of the velocity and acceleration of the boy when t is 3 seconds. So radial direction from the center of the platform with a constant acceleration of 0.5 meters per second square. So r double dot is given, r double dot, because see, this acceleration is given, right? The acceleration along the radial direction, so that is your radial acceleration, which is r double dot, which is 0.5 meters per second square, and theta dot is given, theta dot is 0.2 radians per second, okay, and at t equals to 3 seconds we need to determine everything. Alright, so what we can do is, r dot is the velocity along radial direction. So what we need to find essentially are these components. Let me just copy them again. So what all things are given to us? R double dot is given, this fine. So this thing is given, theta dot is given, okay, and the radius is given, theta dot. R is not given, right? The radius. So I think we'll have to find the radius also, the radial distance. So to put in these formula, what all things we actually need to find, let us just write them down. R we need, R dot we need, and theta double dot we need. Theta double dot, since theta dot is given and it is constant, we can say that theta double dot is going to be 0, right? So theta double dot, directly we can say, differentiating this with respect to time, is going to be 0 radians per second square. So we found one quantity directly, theta double dot. R dot is the velocity along the radial direction. Now along the radial direction, when I consider, see, let us not confuse this with the circular motion and along the radial motion. Along the radial direction, his motion is a linear motion, right? What is causing the circular motion is the theta, the angular velocity. That is causing the theta dot basically. That is causing the circular motion. But along the radial direction, his motion is a linear motion. So what we can do, and it is said that it is starting from rest. So the initial velocity of this person is 0. The final velocity along the radial direction, that is going to be r dot, isn't it? That is the final velocity, v is equal to r dot. Acceleration is given as r double dot, which is 0.5 meters per second square, and at t equals to 3 seconds it is asked. So we can apply this equation that v is equal to u plus at. So I can say r dot, which is actually your radial velocity, r dot is u plus at, which is 0 plus 0.5 into 3. Therefore vr, which is r dot, is equal to 1.5 meters per second. So one more thing we have found out, that is r dot. Now only thing left is r. Yes. So now what you need to understand here is that this r which is there, this r is actually not the radius of this disk. Do not confuse this with the radius of the disk. It is actually the position of this particle at t equals to 3 seconds. Okay, at t equals to 3 seconds. That is, this r is the position of the particle or position of that boy on that disk. It is not the radius of the disk. So that again, since this is a linear motion, we can actually find that using linear equations of motion, which is s is equal to ut plus half at square. That is how much distance he has covered in 3 seconds radially. Okay, so ut is 0, this is r basically. So this is equal to, r is equal to half into 0.5 into 3 square, which is equal to 2.25 meters. So now we have found r dot and theta double dot, everything that we need to develop the total velocity and the total acceleration, everything we have found out. Let us quickly find the total velocity and accelerations. So Vr is 1.5 meters per second. V theta is r theta dot, that is 2.25 into theta dot is 0.2, I guess, right? 0.2 radians per second. So this v theta is equal to 0.45 meters per second. Ar, which is r double dot minus r theta dot the whole square. R double dot is how much? It is 0.5 r double dot minus r theta dot the whole square. 2.25 into theta dot is 0.2 the whole square. That is equal to 0.41 meters per second square. A theta is r theta double dot plus 2r dot theta dot. So theta double dot, we know it is 0. So first term is 0, r theta double dot is 0, plus 2r dot theta dot. 2 into r dot is how much is r dot? 1.5 into theta dot is 0.2. So this is equal to 0.6 meters per second square. The total velocity and the magnitude of total velocity and acceleration we can find. V is under root of Vr square plus V theta square, which is equal to 1.566 meters per second, and acceleration under root of Ar square plus A theta square, which is equal to 0.7267 meters per second square. Fine. Okay, so what is given is that the airplane on the amusement park ride moves along a path defined by the equations r equals to 4 meter, theta equals to 0.2 t, and z is equal to 0.5 cos theta. Okay, so directly what we can see here is that r is fixed along its motion. Okay, so r is not varying, that means this plane is not going to vary along the radial direction. Hence we can say that r dot, that is the velocity along the radius, is 0, and r double dot is also equal to 0. This is one thing that we understand. Theta dot can be said to be 0.2 and theta double dot will be 0, right? This also we understand. Now coming to z. What is z is? Z is in the vertical direction. What we had seen in the derivation was a 2D case, that is in the derivation of these cylindrical components. What we had seen was there was only a radial direction and a theta direction, but that was on a 2D planar surface. But if we give the depth to it, then that would be the z direction, and of course the particle can also travel along that direction, right? So this is what is given here, that we also have a z direction along which the particle travels, and it will only be like an additional thing. One additional component will be added in the equations. So instead of where your final v used to be vr square plus v theta square, now it will have one more additional term which is vz square, that is the velocity in the z direction also. Okay, and see, this is nothing difficult to find out. Let us see. So it is given as z is 0.5 cos theta. What I'll do is I'll directly differentiate it with respect to time. Okay, so z dot will be 0.5 minus 0.5 sine theta into theta dot, and z double dot will be product rule between them. So it is equal to minus 0.5 sine theta into theta double dot plus theta dot into minus 0.5 cos theta into theta dot. So this is minus 0.5. I can take minus 0.5 common. I'll get sine theta double dot plus cos theta dot square. This I'll get as z double dot, right? And it is said that we need to find the velocity and acceleration when t equals to 6 seconds. So everything needs to be found at t equals to 6 seconds. Only now z is given in terms of theta, right? So what we'll do is we will find theta when t equals to 6 seconds, and we'll just put theta here, and similarly theta dot is 0.2 only, and theta double dot is anyway 0. So see, let me make a table here actually. Okay, we will say that r theta z, okay, then r dot theta dot z dot and r double dot theta double dot z double dot. This is what the table would be, and at t equals to 6 seconds. Okay, so we will be having r equals to, at 6 seconds, 4 meters. So r is anyways constant. Okay, r dot is 0 and r double dot is 0. That also we'll write directly, 0 and 0. Theta is 0.2 t, so it is equals to 0.2 t, which is 0.2 into 6, which is 1.2 radians. Z is 0.5 cos theta, so it is 0.5 into cos of 1.2 radians. Okay, This is 1.2 radians, not degrees, so it has to be calculated properly. Therefore, what we'll get Z as 0.1812 meters. See, Z is a quantity of distance. Okay, Z is a distance, so it is meter. Theta dot is how much? 0.2, and theta double dot is 0, so that we'll write directly 0.2, and this is equal to 0. Z dot is minus 0.5 sine theta double dot. Okay, no, minus Z dot is minus 0.5 sine theta dot. So it is equal to minus 0.5 sine theta dot, which is equal to minus 0.5 sine of 1.2 radians into theta dot is 0.2, which is equal to minus 0.0932 meters per second. This is the component of your, basically this is your Vz. Okay, this is your V theta and this is your Vr, right? And Z double dot is minus 0.5 sine theta double dot plus cos theta dot the whole square. So minus 0.5 sine theta double dot plus cos theta dot square. So this would be, this will directly become 0, and so it is minus 0.5 cos of 1.2 radians into theta dot square, which is 0.2 square. So this is equal to minus 7.2472 into 10 raised to minus 3 meters per second square. Minus 7.2472 into 10 raised to minus 3 meters per second square. Okay, and this is your acceleration along the radial direction, along the sorry, not the total acceleration. Means we'll have to find the total acceleration. Let us first find the total velocity. So the total velocity now, it will be V is under root of Vr square plus V theta square plus Vz square, which is equal to 0 square plus 0.2 square, right, plus 0.0932 square, which is equal to 0.8054 meters per second, and acceleration AR, basically we need to find first. AR is R double dot minus R theta dot the whole square, R double dot minus R theta dot square, which is 0 minus 4 into 0.2 square, which is equal to minus 0.16 meters per second square. A theta is R theta double dot plus 2R dot theta dot, which is equal to, theta double dot is 0, so this is 0, and this also is 0, right? So this is basically 0 meters per second square. Hence there is no acceleration along the theta direction, but along the z direction, this is your direct acceleration along the z direction. Okay, this is your AZ. So AZ is equal to minus 7.2472 into 10 raised to minus 3 meters per second square, and your acceleration, total acceleration, under root of AR square plus A theta square plus AZ square, which is equal to 0.1602 meters per second square. So what is given here is that R is equal to 40 e raised to 0.05 theta. Okay, this is a logarithmic spiral, and I think it is kind of like a button of some camera or something. Anyways, that we are not bothered with. Some shutter kind of thing maybe. So yeah, This is called as logarithmic spiral. You can see this type of shapes a lot of there in nature. Even the on the sea, on the beaches, you can find those shells which are there. They are also having this kind of logarithmic spiral. Here, this is rotating at a constant angular velocity theta dot, which is equal to 4 radians per second. So since it is constant angular velocity, immediately we can say that theta double dot is going to be 0 radians per second square. Okay, and what else is it? Determine the magnitude of the velocity and acceleration of the point on the cam that contacts the follower rod at the instant of theta equals to 30 degrees. So we need to find at theta equals to 30 degrees, which is pi by 6 radians. Okay, let me again bring that final equation of v and of what we actually need to find. Okay, so what is given to us is r is there with us. So r is there, theta dot is there. Okay, theta double dot we have found out. This is there. R dot, what is remaining is r dot is left to be found out. R double dot is left to be found out. So only these two things are only there. So r is your 40 e raised to 0.05 theta, right? R is equal to 40 e raised to 0.05 theta. Therefore, r dot will be equal to 40 into e raised to 0.05 theta into 0.05. But okay, now then we'll also have to multiply by d theta by dt, which is your theta dot. And theta dot is 4 radians. And then okay, so instead of that, what we can do here is let us not keep this r in terms of theta. Let us make it in terms of t. And since theta dot is 4 radians per second, theta dot is 4 radians per second, which is equal to d theta by dt. What we can do is d theta integration from 0 to theta is equal to integration 0 to t 4 dt. So theta is equal to 4t, right? So we get theta equals to 4t. This theta I'll substitute here. So I'll get r is equal to 40 into e raised to 0.05 into 4t, right? And that would be 40 into e raised to 0.2t. Now we can take the time derivative of this, which is 40 into e raised to 0.2t into 0.2, which is equal to 8 into e raised to 0.2t, and r double dot is equal to 8 e raised to 0.2t into 0.2, which is equal to 1.6 e raised to 0.2t. So we have found your r dot and r double dot, and now we just have to put t when theta dot becomes, or when theta becomes 30 degrees. So here we can find the time also, that is when theta becomes 30. So pi by 6 equals to 4t. Therefore t will be equal to pi by 24 seconds. This is the time at which we need to find everything. So again, let us make that table only, right? That is better. So we have here r is there, and then r dot, r double dot, theta, theta dot, and theta double dot. Okay. Let us write all the formulas. So r is 40 e raised to, sorry, in terms of t, right? 40 e raised to 0.2 t. R dot is 8 e raised to 0.2 t. R double dot is 16 e raised to 0.2 t. Theta is how much? Theta is 4t, right? Theta is 40. Actually, theta is pi by 6. So that is where we are finding theta is pi by 6 radians. Theta dot is how much? 4 radians per second. Theta dot is 4 radians per second, directly given, and theta double dot is 0. Now at t equals to pi by 24 seconds, r will be equal to 41.0610. R dot will be equal to 8.2122 meters per second, and r double dot will be equal to 1.6424 meters per second. This is going to be 4 and 0 itself. Now this is your VR, okay, and yeah, so we can find the quantities of VR and V theta directly now. VR is nothing but 8.2122 meters per second. V theta is R into theta dot, which is 41.0610 into theta dot is 4, which is equal to 164.2441 meters per second, and total velocity will be equal to under root of VR square plus V theta square, which is 164.4493 meters per second. AR will be equal to R double dot minus R theta dot square, which is R double dot is 1.6424 minus 41.0610 into 4 square, because theta dot is 4, so this is equal to minus 655.334 meters per second square, and A theta is equal to R theta double dot plus 2 R dot theta dot, which is, this is 0, and 2 R dot theta dot, right? So this would become 65.6976 meters per second square. The total acceleration A, the magnitude is 658.6189 meters per second square. So that's it. These were the numericals in the cylindrical component system. So that's it for this lecture. Thank you.